Hey gang, this is Josh from Lead Dev, and in this video we'll be going through another question from the study guide that Scott and I personally used to prepare for our programming interviews that got us multiple offers from bank companies. Please check the descriptions below to learn more about this. So today we're going to talk about the LeetCode problem contains duplicate and the common algorithms and data structures that you should know when solving your next programming interview. Now, before we get started, if you like these types of video, please leave a comment below. Otherwise, please like and subscribe to help us produce more of these types of videos. Alright, today we're going to go through LeetCode problem number 217, contains duplicate. So if we're given an array of integers, we want to find if an array contains any duplicate. So basically, if there are two elements in the array that are the same, we return true. Otherwise, we return false. This problem is pretty simple to solve. You can even see it right there in the top left corner where it says easy. There are three core algorithms and data structure that I want to recognize and go through. So let's just take a quick look at the example. If we are given an array of 1, 2, 3, 1, it would return true because we have a duplicate of 1. And likewise in example 2, if we have an array of 1, 2, 3, 4, we return false because there are no duplicates in the array. And finally, in example 3, if we have an array of a gigantic number, we will return true because we have quite a few number of duplicates. For example, the 1s and the 3s. So let's get started. Now onto the whiteboard. So just like the problem statement, we have an array of 1, 2, 3, 1, which will return true because we have duplicate 1s. Now, at the start of an interview, the first thing you should jump to is the brute force solution. That's typically a n-squared solution where you just try every single combination. We have a pointer, first element, that. And then we have a second pointer, inner for loop, and we just try every combination. And then in this instance, we'll find a duplicate and we'll return true. Of course, if we don't find anything, we'll just continue going through our array and just keep going until we eventually reach the end. And here's the animation of our n-squared brute force solution. Here's our array of 1, 2, 3, 2. And to represent the array, we have two variables I and j, which will represent the outer for loop and the inner for loop to traverse through our array. We have our I arrow, and then we have our j, which represents the inner loop. We update j to be 1, and we'll just go through our array, and we'll find no duplicate. And then now that we haven't found any duplicates of 1, we move our outer loop I to be the second index, or first index, 2, and then we have j start at the next index. And we go through the array and we find a duplicate right there. However, if there is no duplicate, we'll just keep going through our array and eventually we'll just try every single combination, which would be an n times n solution, which will give us an n-squared runtime worst case. Now let's see if we can do better. Now, if we submit that as our answer to our interviewer, we will most likely fail the interview. In fact, I'm guaranteeing you'll fail the interview. So we have to brainstorm what's a better solution. The next best runtime to an n-squared algorithm, a brute force, is a n log n algorithm, which typically involves something like sorting or a heap or binary search, iterating with a binary search. One great property that we can take advantage of to detect if there's a duplicate is that if there is a duplicate number, it has to be the same number. So what that means is if this array is sorted, we can just do a scan across the whole array and just check to see if any two numbers are the same. So if we were to do a quick sort, which is a n log n runtime, we would get an array of 1, 2, 2, 3. And then we can just scan through the array. Just ideally start at the first index right here and just check the previous index. And just continue checking to see if if the numbers are the same. So in this instance, no, it's not the same. 1, 2 is not the same. But if we try and check the next index, we'll see that 2 and 2 is the same. And of course, if there's no duplicates, we'll just keep going, and then we'll just return false at the end of our loop. So that's a n scan plus a n log n sort, which would give us a runtime of n log n. Now here's the animation for the n log n sorting algorithm. Once again, we have our same array, 1, 2, 3, 2, and then we sort it, and we make it 1, 2, 2, 3, and this is a n log n algorithm, mostly because we're probably using a quick sort or a merge sort algorithm underneath. And like before, we have a for loop. We just start at the second index, specifically index 1 at 2, and we just check the index before it. And then we just checking, iterating, and then we find that we have a match when our I is at index 2. And of course, if there's no match, we just continue iterating through the loop until we reach the end, and then we return false. A n log n solution is not horrible, but typically for an array problem, the optimal solution usually requires a runtime of O of n. So how can we get a runtime of O of n? If we want an O of n runtime, that usually means we have to iterate through the array once. Now, is there a way we can do that? If you think about it, what we really need to do is store the values that we've seen. One great data structure that helps you accomplish this is to use a set, or specifically hash set, where it takes a O of 1 runtime to store a variable. Set. And then add. It is O of 1. And to get an element from a set, it is also a O of 1 runtime. So while we're iterating through our array, we can just store everything in our set. I won't draw the set out because we'll animate it later, but we'll just go through our array, add our 1 to our set. On our next one, check if 2 exists in our set, and then add 2 into our set if it doesn't exist yet. Same thing with 3, check if 3 is inside our set. If not, continue and add 3 into our set. And then finally we get to 2. Is 2 inside our set? Yes it is. That means we found it, and then we found a duplicate. We just need to return true. And of course, if we never find a duplicate, we just finish traversing through our array and return false. And finally, we have our O of n set algorithm. So once again, we have our array 1, 2, 3, 2, and then we have I to represent the index we're located at as we iterate through the array, and we have a set variable that will contain all of the integers that we've seen so far. So we start at 1, we don't see anything yet, and then we add 1 into our set, and then we continue. And then at I index 1, we add 2 to the set. Or first, we see that 2 is not in the set, and so we add it 2 in our set, and then we continue. And then at index 2, we see that 3 is not in the set, so we'll add it into the set and continue iterating. And then finally, at index 3, we see that there is a duplicate, so we'll return true. Now, of course, if there is no duplicate and the array is completely unique, we would just end our loop and then return false. Now, at this point in the interview, you have brainstormed a good solution for the interviewer, and the interviewer seems very happy about it. So now it's time to go on the whiteboard and write your code. Or in my case, I will just cheat and copy and paste my solution. Just like what we talked about, the optimal solution requires a hash set, or a set specifically, to remember the integers in your num array that you've already seen. So that's what we do here. At line 3, we instantiate our hash set, which gives us a O of 1 add and a O of 1 retrieval. And then it's simply just iterating through our array of numbers, and if we see the number in our set, we just return true. Otherwise, we just add the number into our set and then just continue iterating through our loop, going through every single number until we find a duplicate and then return true, or we have no duplicates in the array and then we exit our for loop and just return false. And that's all there is to this algorithm. It's a simple hash set strategy where you store everything you've seen before and then check to see if you found something. Now to prove that this code works, hit submit, and bada bing, bada boom, you got 6 milliseconds. And that's it for all of the algorithms and data structures used in this specific LeetCode problem. Now to recap on everything that has happened. We used a O(n)² brute force solution to try every possible combination to see if we could find a duplicate in our array. And then the next best step is we did a O(n log n) solution where we sorted the array so that all the duplicate numbers are next to each other. And then we just do an O of n scan through that array so that we can see if there's any duplicates. And then finally, for the most optimal solution, we used a set that would keep track of all the numbers that we've seen as we iterate through our array. And then if we found a duplicate, then we return true. Otherwise, we just keep going until we reach the end. And that's a wrap for this LeetCode problem. Hopefully you've learned something helpful that will prepare you for your next programming interview, or at least refresh your mind about some of the algorithms and data structures that are available that you can use. If you have any feedback, please leave them in the comments below. And otherwise, if you found this helpful, please like and subscribe to help us grow our channel and keep producing more content. This is Josh from LeetDev signing off.